Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer questions from sample paper number 1, RK BALI 4th edition navigation book. If you happen to have any other edition book like the 5th, the 6th or the 7th, no problem. The questions are still the same whether you take any edition book. So now let's begin with question number 11. In my previous video lecture, I have solved the first 10 questions. So do watch that if you haven't yet. Aircraft flies following Rhumb tracks and distance from starting position 4° north 30° west. From this position it flies 700 miles south, then it goes east, flies 700 miles east, then 700 miles north and then 700 miles west. What is the final position of aircraft at the end of its flight? So let's start drawing this. So we have initial position is 4° north 30° west. So that means let's say this is your earth. Here is the equator, 0° equator. The first position is 4° north, 30° west. Now from this position the plane flies 700 nautical miles south. Okay, so this is great circle distance is 700 nautical miles. Now how is it a great circle? By definition, great circle is nothing but flown along two different latitudes at same longitude. So the longitude is the same, 30° west longitude is the same. You are flying along this longitude. Starting latitude is 4° north. The ending latitude may be something new. We will find that out. So let's apply great circle formula. Great circle distance is d lat in degrees into 60. So 700 nautical miles equals to d lat in degrees into 60. So d lat in degrees will be equal to 700 divided by 60, that is equal to 11° 40 minutes. 11° 40 minutes south. That means flight is going in the southerly direction. Therefore, the difference is 11° 40 minutes towards south. So your final position will be it will be in the southern hemisphere. How? Now out of total 11° 40 minutes south, 4° 30 minutes correction 4° will be spent in traveling from 4° north towards the equator. At equator it will be 0°. Then remaining d lat will be traveled in the southern hemisphere. So 11° 40 minutes south difference can be divided into two parts. 4°, which is this part, and remaining difference is how much? 11° 40 minutes minus 4°, 7° 40 minutes. 7° 40 minutes. So new position will be 7° south and 30° west. 7° south, 30° west. Next, from this position we fly 700 nautical miles east. So we are flying 700 nautical miles east to a new position here. Correct? So when you fly along a fixed latitude is the same, 7° south. And between two different longitudes, this longitude is 30 west. This new longitude we will find that out. So that will be, I am writing here, Rhumb distance equals to d long in minutes into cos of latitude. So 700 equals to d long in minutes into cos of 7. So d long in minutes equals to 700 divided by cos 7. Cos 7 is 0.99. So 700 divided by cos 7 is 705 minutes. 705 minutes, which is equal to 11 degree 11 degree 45 minutes east. That means new longitude will be 30 degree west minus this difference. Why minus? Because now you are in the western hemisphere 30 degree west. When you are in the western hemisphere and you travel eastwards, the values of longitudes decrease. So new longitude will be old or initial longitude minus d long. What is the initial longitude? 30 degree west. What is d long? 11 degree 45 minutes. So 30 degree west minus 11 degree 45 minutes is 18 degree 15 minutes west. 18 degree 15 minutes west. From this position, the plane flies northwards for another 700 nautical miles as given in the question. The plane flies 700 miles south. So when it flies 700 miles south just like this, again d lat will be the same, 11 degree 40 minutes south. Okay. Out of that 11 degree 40 minutes south, you will travel 7 degree 40 minutes in the southern hemisphere and the remaining 4 degree in the northern hemisphere. So again your new latitude will remain the same, will be same 4 degree north. It will be 4 degree north. Okay. And longitude will be 18 degree 15 minutes west. So we will do this. I'll show you again. Great circle distance equals to d lat in degrees into 60, right? So d lat in degrees will be great circle distance 700 divided by 60 is 11 degree 40 minutes. 11 degree 40 minutes. So our new latitude will be first 7 degrees south latitude. So 11 degree 40 minutes minus 7 degree is 4 degree 40 minutes. So I have divided this full latitude of 11 degree 40 minutes difference into two parts. 7 degree will be traveled in the southern hemisphere from this point up to equator, and the remaining 4 degree 40 minutes will be traveled in the northern hemisphere. So new position is not accurately 4 degree north, but it is 4 degree 40 minutes north. 40 minutes more than the 4 degree north latitude. So little bit above over here. 4 degree 40 minutes north latitude. Correct? And longitude is the same. 18 degree 15 minutes west. Now from here we travel again east, correction, again west for 700 miles. Okay, so we are traveling west again 700 miles somewhere here. So what will be our new position? Now remember our new position will be beyond 30 degree west, 30 degree, 31 degree west, 32 degree west, some a little bit beyond 30 degree west. Now why is that? Because on the earth we have convergency of meridians. We have convergency of meridians. Let's say this is your equator. This is 7 degrees south latitude. This is 4 degree north latitude. Now as your latitudes increase in value, convergency between meridians, two meridians, that is intersection, the crossing increases. Let's say these are the two meridians that we are discussing in the question. So convergency between these two meridians at 7 degrees south will be more than the convergency at meridians at 4 degree north latitude. Okay, 7 degree latitude is more than 7 degree is more than 4 degree. So 7 degree convergency will be more than 4 degree. So now here we have 7 degree south latitude and 4 degree 40 minutes north latitude. So 7 degree is more than 7 degree is more than 4 degree 40 minutes. So convergency at 7 degree will be more than convergency at 4 degree north latitude. That means, I'm erasing this, that means 700 nautical miles, I will show it here. 700, if 700 nautical miles at 7 degrees south latitude is this much, 4 degree north it will be only this much. Okay, so we have this space remaining because when convergency is more between two different longitudes, the distance between them will have to be exceeded. Okay, but over here since convergency is less, the difference between d long is the same, so, but distance in nautical miles of kilometers will be covered in a short distance. Over here it will require longer distance. So the final longitude will be somewhere here. Not like before. I said previously I said beyond 30 west longitude. That is wrong. Before 30-degree west longitude, 29-degree west, 29 degree 30 minutes west, something like that. So we will again apply Rhumb line distance formula. I will show it to you. Equals to d long in minutes into cos of latitude. 700 divided by cos of 4 degree 40 minutes equals to d long in minutes. So 700 divided by cos of 4 degree 40 minutes is 702 minutes. 702 minutes is 11 degree 42 minutes. Now our initial longitude is what? 18 degree 15 minutes. From here when you travel westwards, the values of longitudes increased. So what you are going to do is 18 degree 15 minutes initial longitude plus d long 11 degree 42 minutes, that is equal to 29 degree. New longitude is 29 degree 57 minutes. 29 degree 57 minutes west. So options are 4 degree north, 4 degree north, and latitude is 29 degree 57 minutes. So closest option is option C, 29 degree 55 minutes west. I have got 29 degree 57 minutes west. So this is how you do it. A long sum but very important. Aircraft at position 60 north 5 degree west tracks 90 degree east for 350 kilometers. Now 350 kilometer divided by 1.85 is 189 nautical miles. On completion of the flight, what will be the new longitude? So, so we are at 60 north in the western hemisphere, 5 degree west. From here, we travel east for 189 nautical miles. So when you travel easterly direction or westerly direction along a parallel of latitude, you are actually flying a Rhumb line distance. A Rhumb line distance is d long in minutes into cos lat. So d long in minutes will be equal to 189 divided by cos of 60, which is equal to 189 multiplied by 2, is 378 nautical miles. 378 nautical, correction, 378 minutes. D long is 378 minutes, that is equal to 6 degree 18 minutes. Divide by 60, 6 degree 18 minutes. So your new longitude will be initial longitude plus D long. So 5 degree west plus 6 degree 18 minutes. Now how will this 6 degree 18 minutes west get divided? Remember, we are at 5 degree west. Let's say this is your earth. There will be prime meridian in the center. Your 5 degree west longitude is here. Now if you see D long is 6 degree 18 minutes. 6 degree 18 minutes, that means 5 degree this much and another 1 degree 18 minutes in the eastern hemisphere. In the eastern hemisphere, correct? Total D long is 6 degree 18 minutes. So 5 degree in the western hemisphere, remaining 1 degree 18 minutes in the eastern hemisphere. So new longitude will be, what will be the new longitude? This will be 1 degree 18 minutes east. Option Charlie. Okay. So new longitude equals to old longitude. Okay. New longitude equals to old longitude after that old longitude of 5 degree. Okay, and then we have a prime meridian in the center, and then from this prime meridian we will be traveling another 1 degree 18 minutes east. Circumference of the earth is approximately how much? So remember this value, it is 21,600 nautical miles or 40,000 kilometer. Next, question 14. Aircraft is over a particular location 55 degree 30 minutes north, 60 degree 15 minutes west, where and VOR is at 53 degree north, 60 degree 50. So same longitude but different latitude. Aircraft is over VOR. That means aircraft is at a higher latitude compared to the VOR latitude. Aircraft is to the north of VOR. Variation at aircraft is 31 west. Variation at VOR is 28 west. What is the radial from VOR? So on what radial is aircraft situated? So we know that VOR station is to the south of aircraft. So aircraft is to the north of the VOR station. Okay, this is the north direction. So if this is your VOR station and aircraft is directly to the north of it, that means we can say aircraft is situated on radial 360 true. Okay, this radial is 360 true direction. But all VOR radials are magnetic in direction, correct? Magnetic in direction. So we will have to convert this true direction into corresponding magnetic. Now here there are two variations, two different variations given to us. One variation at aircraft position, another variation at VOR location. So we are going to use the variation which is at VOR location 28 degree west. In case of NDB questions, you are going to use variation at aircraft location. So now variation west magnetic is best. That means radial in terms of magnetic will be 360, also known as 000, plus variation. Variation best means magnetic is more than 2, so add the variation given to you. So 000 plus 28. So aircraft is actually situated on radial 0 to 8 in terms of magnetic direction. Okay, so option Charlie is the correct option. Okay, so pay attention to the location. Both are located on same longitude. Both aircraft and VOR are located on same longitude, 60 degree 15 minutes west. That's why we say that aircraft is to the north of VOR station, because we know that aircraft is at 55 degree north, VOR is at 53 degree north. So in the northern hemisphere, as you travel northerly direction, latitude increase in value. Now distance Q to R is given, ground speed outbound, homebound are given, endurance is given. What is the distance from the departure to the point of safe return or no return? So very important, let's use the direct formula. Distance to PNR equals to endurance into outbound speed into homebound speed divided by outbound plus homebound. What is endurance? It is 7 hours. What is outbound speed? It is 380. What is homebound speed? 470 divided by 380 plus 470. So 380 plus 470 is 850. 7 into 380 into 470 is 1250200 divided by 850 is 1471 nautical miles. 1471 nautical miles. Option A. Question 6. What is the strength of the horizontal component of the Earth magnetic field at magnetic North Pole? Now, let's say this is the surface of your Earth. This is the Earth. Here is the equator. Here is the North Pole. Now, at equator, what happens? Horizontal component of the Earth magnetic field is maximum. And to the contrary, vertical component of the Earth magnetic field is minimum. But at poles, when you go to the poles, the difference between horizontal and vertical component can be seen easily. So as you travel to higher and higher latitudes, horizontal component will decrease in value and vertical components will start increasing in value. Finally, when you reach the poles, vertical component of the Earth magnetic field, vertical component of the Earth magnetic field will be maximum and horizontal component will be minimum. That means horizontal component will be zero, no horizontal component at all. Horizontal component is minimum. Okay, so it is zero. And over here, at equator, vertical component is zero. Okay, and your magnetic compass requires horizontal component of the Earth magnetic field to function. So question 16 will be answer 0. A direct reading magnetic compass will be influenced or affected by adjacent electrical equipment. Yes. Ferrous metals means steel and all that. Yes. So option 1 and option 2 are the correct options. Non-ferrous metals like wood, no. Plastic, no. That these things won't affect or influence your compass functioning. But electricity, ferrous metals, this all influence or affect your magnetic compass. It will induce deviation in it. Question number 8. When aircraft lands on a southerly heading, in the south hemisphere, the direct reading magnetic compass will indicate no apparent turn. Why? So, let's say this is your Earth, okay? And this is the north pole, this is the south pole. Now your magnetic, the runway is oriented north and south, is oriented north and south. Now when you are landing on runway, you are landing on runway 18. So your aircraft is landing on runway 18. It's landing on runway 18 like this. So your magnetic compass is subject to two types of errors: acceleration, deceleration error on east and west headings. Now that this particular error, acceleration, deceleration, is irrelevant or is not required in this question. Second type of error is turning error. Turning errors happen around north direction and south direction. When you're turning, okay, only and only when you're turning around the north pole or northerly direction or southerly direction, like that. But in this case, you are landing on runway 36. That means you won't be turning your aircraft. You will land straight ahead, follow a direction of runway, follow a direction of 18 and land straight ahead. So if you're not turning your aircraft, you won't be subject to any turning errors. Okay. So no apparent turn because you will be landing straight runway 18. Next. Last, which of the following concerning great circle on a direct Mercator chart is correct? Great circles, with the exception of meridians and equators, are curves concave to the equator. Concave to the equator means convex to the poles. Concave means bending away from something. Convex means bending towards something. So always, if let's say this is your two longitudes, so you are in the northern hemisphere, so great circle will pass to the nearest north pole. If you are in the southern hemisphere, the great circle will pass through the nearest south pole, like this. This is your great circle. So here it says there are curves concave to the equator, means this is, let's say this is your equator. So it will be concave to that, bending away from that. Convex to the pole means, convex means bending towards something. So it is going towards the poles, that's why convex. So this can be used interchangeably. Pay attention. The center cannot be that of the earth. They are represented by straight lines. The correct answer is option A. On a direct Mercator chart, great circles are curves concave to the equator or convex to the poles. Remember all the properties of all the charts: Mercator, Lambert's, polar, transverse Mercator, oblique Mercator chart. Okay, very simple properties and easy to remember. And when you remember them, you will get full marks to all these theoretical questions related to them. So very scoring. Don't omit that out. So do that chapters very well. So I'll stop here. I hope you have understood all the 10 questions I have done in this video lecture. Let me know your comments, feedback, doubts, questions in the comment box of this video. In my next video, I will be answering the next 10 questions. So don't miss that video. Share this video with all your friends. Subscribe if you haven't yet. And please hit the like button if you have liked this video lecture. Best of luck.